Perfect.
All right, Brian, thank you so much for joining us. I understand we're waiting on one additional person. While we're waiting, allow me to introduce myself to the rest of your team. Guys, my name is Jay Ayala. I work for Autodesk as a technical specialist. I'm based out of Hillsboro, Oregon, on the west side of Portland. And today, it's my pleasure and my privilege to present a little bit of Autodesk point layout for Brian and, of course, everybody else there at Harvey's enjoying the both the presentation and the recording. And with me is Justin. Justin, we have
guys.
we have planned to maybe go visit at some point, right, Justin?
Yes. I talked to Justin Dittmar, and he wanted me to get with you, but I was going to talk to you about that today. So basically, next month, the 6th, 7th, and 8th, I believe that's a Monday, Tuesday, Wednesday, if that works with your schedule, or we can do, what works for you, because we need you up here. So then maybe we can talk about that after the conference and see, what time works best for you. But Brian, you were saying that worked for you guys, right?
That works perfect for us, yes.
Okay. So
I'm sure I can make that work, yes.
Okay.
So Brian, if you don't mind, for the sake of the recording and the people joining us that weren't part of our conversation yesterday, would you mind kind of giving us a little bit of a recap on what you have found with Autodesk Point Layout and how you guys do your day-to-day business?
Absolutely. So right now, basically, we are, Harvey's Plumbing and Heating is based out of Bozeman, Montana. We do a lot of high-end residential construction up in the Yellowstone Club. Some of the houses range between 6,000 square feet, 22,000 square feet. Some are even bigger than that. And what we do is we'll receive an AutoCAD drawing or a building information model drawing from the architect. And what my job is to do is, through our design team, we're supposed to coordinate our plumbing and HVAC equipment, or both, into a drawing, and then get that information out to our guys in the field. So I started researching it, and my boss, along with our design team, we're focused on really high level of detailing. So what we're trying to accomplish is basically being able to design these systems in a functional manner that'll work out in the field with the truss layout, as well as the residential home layout, which is pretty challenging right now, especially with the plumbers, because they'll go out there based on our dimensions, and we have no way of getting their feedback of like, oh, it's off 2 inches, and then making that adjustment into our model. So we found point layout, and it seems like that might bridge that gap of that disjunct of lack of information that we're able to carry back and forth between the two. And so that's what led us to you guys.
Great. Okay, great. So high-end residential, and we're trying to give our dimensioned drawings to our plumbers, and there's a disconnect with feedback.
And it's not necessarily feedback, it's more coordination with the structural framing of the home. So basically, if I gave him a double fixture or double lav setting where it has the drain and the vent in the wall, and I say, okay, well, on the plan it looks great right here, but then he gets that plan out to the site and he finds out that there's a stud in the way. He comes back and says, okay, well, I had to move it 2 inches to the right, or, so far to the right or so far to the left, and I need to be able to coordinate that movement with my design so that what I'm drawing is actually a replication of what's going to be existing in the field, for field conditions. And then from that point, once that's coordinated, we'd like to fabricate a lot of these assemblies. And so I feel like with point layout, if we had, the accuracy of knowing, okay, well, there's a stud here, so I had to move it 2 inches this way. Therefore, this is where you're going to be venting, this is where you're going to be draining. I'd be able to coordinate that with the model, and then in turn be able to fabricate knowing that the dimensions are accurate from the field.
Sure, understood. So I like the way you're thinking about that. So what I have today is just a short demonstration. Really, it's going to be like 10 or 15 minutes, maybe 20 at the max. but it's enough to give you a really good comprehension as to how you're going to execute on, first of all, your Revit model, and then using Autodesk point layout to send this information back and forth. Unfortunately, I can't demonstrate for you receiving it out in the field without my robotic total station, so that we'll have to make up probably when I visit. But this will give you a really good comprehension as to how that's leveraged.
Okay.
Brian, just a quick verification. Can everybody see my screen okay?
Yes.
All right. Do you see these mysterious red rings around all of my vertical piping?
I do, yes.
So from our conversation a couple of days ago, Brian, we were talking about how do we do the stub-ups. That was one thing I wrote specifically down in my notes, which I decided that's probably what I should focus my time on demonstrating for you guys. Of course, we can also do the horizontal, and those points that you're seeing populated kind of throughout the model, those were automatically placed. I think it took me 12 seconds to place roughly 2,000 points or whatever the list is right now. So, I mean, when we take a look at how this is done, it's done very quickly. It's done very, very fast. Now, I understand you guys are doing residential, so I expect that there's going to be a lot less piping stubs throughout your buildings as opposed to a commercial building application. But as you go through this model and as you see this, just don't get overwhelmed by what you're seeing. I mean, there's a lot of points out there, and at some point,
Right.
you know, some of these are duplicate because, as you can see on this urinal, we probably wouldn't even use any of these stub locations here, but let alone that, you know, they're vertically stacked, so there's probably duplicates there that we probably wouldn't need. So just a few notes on that. Okay, so my goal is to show you guys kind of a Revit model, and let me flip up to a better 3D view here of the building that we're looking at. I've turned off some of the Revit links. This is to give you kind of an idea of what this actually, this building actually looks like. It's about, I guess, 180,000 square feet, and there's a few classrooms and stuff here. Oh, maybe that's not this building. I think it's a different building. This is a smaller building. But you can see I've got all my stuff modeled here, the plumbing and the ductwork. Brian, I'm expecting that you guys go to this level of detail with your models, plumbing and ductwork and stuff like that?
Yes.
Okay. So the great thing about Revit in particular, it's a purpose-built modeler, and when you model your plumbing and your piping, as you can see, you know, I got some pipes here. Traditional plumbing plans, you know, when you look at them, they're all drawn with the lines separated for clarity. Now in Revit, that's a little bit different because the piping, it's going to be drawn exactly where it's going to be laid out. It's a 3D representation of the real-world parts. So when you look at a plumbing plan in Revit, it looks a little congested. So, I mean, I'm sure you guys get this already, but here's my plumbing plan, right? And I've got it set up to the wrong detail level. But I can take this down to a single line, and you can see how all of my plumbing it just piled up on each other, and can't really tell what's happening there. So what I want to do is I want to clarify, you will be modeling where the objects belong. And even though the plan may look incomprehensible, sending this information out via points to a robotic total station, it actually helps out. Instead of spending time dimensioning to your column lines or to your studs, you're just going to very quickly go through this process of adding these points and exporting them out to a robotic total station. So my goal is to show you how to do that. So I want to start this drawing over and get you to that point. Brian, is there any other things that I should focus my time on?
I think that's pretty good if you go over that
All right.
in terms of prepping it. My other question would be, like, you automated those points. Is there a way to manually place your points so that you know? I mean, because sometimes when you automate things like that, you know, things are going to get thrown in that may or may not need to be labeled as a point. So would it be more efficient and less error prone to do it manually? I know it would be more. I know it may not be more efficient because it could take more time, but in terms of it giving you information that you need without any error, do you kind of understand what I'm saying?
I do. I do.
Yeah.
I'll go over some of that. And, of course, we'll have an open dialogue as we go along through the demonstration. All right, so let's do this. Allow me to restart this file. I'm not going to save any of my changes here. And we'll start from scratch. All right. So obviously, you guys are using Revit 2015, and the nuance here is that you guys are using Siskiyou. So what I'm going to show you is on Revit 2015, with the exception that I don't actually have Siskiyou or those components. So you're seeing just the standard Revit functionality. Now, I'm applying the piping and stuff. Those are just standard system families, and I came to learn the other day that evidently Siskiyou does system families as well.
Correct.
All right, so theoretically this should be all the same with the exception of content. All right.
100%, yeah.
All right, so here's the 3D model. We've got cable tray, we've got conduit, we've got piping, of course, plumbing pipe, and we've got a whole bunch of ductwork in the way here. So the idea of getting this, the stub ups, right? We want the stubs. All the vertical piping, we want the location of those. So here's how we go about this process. And we could do horizontal as well, but let's stick with one thing at a time. I like to work in plan view. I don't know about you guys, but I mean 3D is great and everything, but this is traditionally where I spend most of my time.
Yeah.
And you don't have to do it here, but this is somewhere where I think it's very easy to do this. All right, so I've got my my restroom here in this commercial building. You guys could probably do the same with a kitchen area or another restroom in your residential building. Super simple. Up at the top, you're going to see Autodesk Point Layout. And the thing about Autodesk Point Layout, it's not your traditional Autodesk software. As opposed to being like an AutoCAD or a Revit, it's a standalone platform. It's actually a plugin. It's a plugin that goes into AutoCAD. It's a plugin that also goes into Revit, as well as Navisworks. And we can get points and create points and all of that. Here's how we do this. Here's your manual point on the far left. And you can just say, it's of these categories. So by selecting one of these tabs, you're already starting to define the parameters of what's going to be pushed out into the field. So if we wanted to do like pipe work, I would put it on the pipe hanger category, and I would give it a prefix. Maybe this is a let's see, I don't know what it could be. Let's just call it J, the prefix J. And then I like to do the numbers, the point numbers, by the floor level. So if I'm on the second floor, I'm going to start with the number 2,000. If I'm on the third floor, 3,000. If I'm in the basement, I start with 0. All right, and then you can give it a description. So what is this that we're about to place? Let's say I'm placing some pumps, some sort of mechanical equipment. So ME for mechanical equipment, and then the prefix will also be ME. So I can just start to place my points on the current work plane or on an element. So I like to do it by work plane. So I'm in the first floor. Maybe there's a pad here, an equipment pad, and I'm just going to place my points. Now this is the manual process of the points, right? I just place 2 points, and I can add my tags to those points. And I'll just add all of them and include leaders. So what this does is it just kind of calls out, okay, you've got some points, and here they are. Now if I zoom in really closely, you're going to see those points. And the point, it's a family. I can double click on the family. It's just a Revit family. And it's a 1 by 1 by 1 cube. Now this 1 by 1 by 1 cube, it's kind of hard to see in the floor plan. So what I like to do is I like to add a ring around that family. All right, so here's something very simple. I'll just do this very quickly here. and I'll go to like the front view. And I will add a ring using the revolve command and a little circle. There's a 1/2 inch circle over here. And then I want to just add a quick dimension. But this is like a 1 foot diameter. So let's just go ahead and change that to 6 inches.
Nice.
Right? And then I will select my axis and then finish it up. So what you're going to see now is that this has a ring all the way around it, like a 1 inch ring all the way around it. And I'll just load that into my project. So you can make it look like anything. You could make it look like a cone, for instance, to show that the point of the cone is where the point lives. But I think this is good enough.
Right. So, quick question. This is Tyler Graff, by the way, again.
Hi, Tyler.
Editing that square, or sorry, that cube, you change this. So you said that you can make a cone, for example.
Yeah.
Changing that cube itself, will that create any problems in the family, or can you make that shape in the center, the cube that it is now, the 1 by 1 by 1 cube? Can you make that into something more, I guess, like something that has more of a point at the very end of it, without damaging the point system layout?
Yeah, the graphics of the point it doesn't matter. The only thing that matters is, let me double click and show you. The only thing that matters about this, let's go to a front view, another view. You'll notice that the reference level here, the floor level, and the crosshair here, the origin, you'll notice that the cube is the center of the cube. So whatever your graphics wind up being, if you make a cone and make it look like this, you want to make sure that that little point over there is at the origin point. Does that make sense?
Cool.
That's the only important part about this.
So my next question, and I'm sure you'll get into this with the presentation, but let's say that point, you drew it on a work plane. Let's say that there's a wall there that has a stud right below that, and that origin's within the stud. When you go out to the field and you set your layout and your laser to the top of that stud, is it going to move that point up 1.5 inches to account for the stud?
Yeah, so let's say there's a stud in the way, right? That's what we're talking about. Let's say like there's a stud that's already mounted on the floor.
Yep.
So what it's going to do is it's going to account for the X and Y and the Z. Now, you can nail it on the X and the Y, but you can also tell the robotic total station to take up that 1.5 inch stud.
Nice.
Right? So what it'll do is, or what is it? Yeah, 1.5 inch stud, right? 2 by 4. So it'll actually account for that gap.
Nice.
Now, one final thing that I like to do, regardless if I'm in plan view or in 3D view, I like to use a view filter. And I color code that with a solid red pattern. So instead of having that point, invisible at this scale, at this view, I can now see them pretty easily.
That's awesome. Yep.
Right? All right, so here's where the magic happens. You just saw what I did with manual points, okay? We also have automated ways of doing this. And I can do wall points, so if there are any penetrations that I have to account for, I can identify those and hand those points off to the guys that are doing the studs so they can block out, I don't know, a big round penetration or something, right? I can also do the pipe points. Now earlier you saw I had fat fingered it and I actually did conduit points, but it's pretty simple. Here's pipe points. Now I just follow the prompts very, very quickly. It took me about 12 seconds. It'll take me longer here to demonstrate this, but very simple. Select all pipes in the view or fence off a selection. Now if I was just working with the restroom, I would fence this off. Does that make sense?
Yep, yeah.
If I wanted everything, I would just pick all. Okay, so now we have a choice. Do you want to do the verticals? Do you want to do the horizontal? Or do you want to do all of the pipes? So what I want to do, I just want the stub ups. So I'll do the verticals. And then it says for the pipe, you're going to mark the points along the run. Do you want to do the top? Do you want to do the bottom? Or do you want to do both? And earlier I had done both, but maybe all I really want is just the bottoms.
Yeah.
Right? So I can also do along the run, and it'll just kind of populate along the run. So I'll just do the bottoms. And then it asks me, you know, what do you want for the description? I'm just going to use the standard description, which is, I think, pipe points. And then do I want to append the diameter to the description? And normally, yeah, you want to do this because it makes the guy out in the field, it gives him very good information about executing on his you know, layouts that he's doing for that day. So what you're noticing here is that I just populated the points for everything, every single pipe in this project, and you're even seeing some of the points that are placed for pipes that are out of the view range, or pipes that have been turned off in this view. All right, so what does that look like? So let's go take a look very quickly at the 3D view. I think this is where we started earlier. I think I wanted the MEP view. All right, so here's that restroom area that we were just dealing with. And you can see that at the bottom of the pipe, there's a ring all the way around it. And let me do my filter one more time. So once you establish your filter, all you have to do is just give it a parameter, a color for the pattern, and then a pattern, identify the pattern itself. So this helps me visually see where all those points are. Now the cool thing about this is if I look at this particular point right here, I'm going to see that this is, oh, that's a conduit point. That's interesting. I thought I hit the pipe button. But this here says that it is 1.25 inches. And if I look at this other one, this is kind of a larger pipe, right? So if I go look at this one, that's a 3-inch. So it's automatically reading the data, the parameters of the pipe as it's being placed, which is very helpful, very useful when I'm sending this information out to the field. There are 5 pieces of information that go to the field. The point description is one of them. Okay? Point description, this is one of the pieces of information that gets sent out to the field. The other 4 pieces are the point number and the X, Y, and Z coordinate. The X, Y, and Z coordinate.
She's actually the other one.
I'm sorry, was there a question?
Will do. Bye.
Yeah, so basically what we would love to do, and you discussed this the last time we talked, is once our model is designed, we run those manual points just like you did, or automating it off the bottom where it's penetrating through the floor slab or through the top of subfloor, wherever it's penetrating. And then getting to this point where you have the point description and point number, we would like to know how to print that data to an Avery label so that our guys in the field could associate that to that point.
Okay, Avery label.
Yeah.
Super simple. All right, so what we want to do is we want to, I just want to talk about one quick thing. In the plan view, we want to establish known points, okay? Now a known point could be a manual point. It could be, typically you want to do control points. So you want to identify a control point. Let's go ahead and place points on the work plane. So maybe it's the corner of the wall. Maybe it's, I don't know, maybe it's the center of the stud track. You guys figure that out, but you just need to have some control points. What we will do, okay, what we will do with these control points in blue here, I will set up my tripod with my robotic total station, right? So, and it will lock into the building control points and triangulate its location.
Nice.
Sorry about that, guys. How rude. I was getting a phone call on my other line at the same time. Okay, so now that you use these control points, what we will do is we will export this information out, okay? So here's the export, here's the import button.
Nice.
Now, how do you want it? Do you want it in northing easting? This is important for surveyors. Or do you want it XYZ format, the way we're typically used to it in CAD? You can choose all of these things. But here, the biggest part of this is you can select all of the points that I've just created. You could tell it to use a particular coordinate system. Excuse me. And then you can save this out to whatever location you need to. So file location, I will place this, I guess, on my C drive to find it easily. And then I'll export this. So what this does is it does a lot of things. It checks for duplicates. If there are any duplicates, it will automatically renumber points so that there's no duplicates ever, right? So it created 253 points, right? And typically that'll take me, like I said, like 12 seconds to run through the dialog boxes to get that to populate. All right, so what did that do? Let's go ahead and look at my C drive here. Give me 1 second. Oh, look at that, I'm almost full. So here's my points that I just created. And it's just a CSV file. From here, I could just print this to whatever Avery label template I would need, right? So here we have the point number, the XYZ location, and then, of course, the description of every one of these points. As you can see, the list just goes on and on and on and on.
That's awesome.
Right? So at this point, I would print this. You know, I'd format it for the Avery label. Of course, I'd get the template and just start printing the Avery label. The great thing about this is you could find a point, mark it with a Sharpie, and then put your Avery label right next to that point.
Question for you. So, for example, we were talking with the owner about how these labels would happen or how we put them down. And most of the time, you know, we probably don't need to know all this information. So as far as editing, I'm guessing you just, for placing the Avery, once you've made this list, before you actually print out the Avery labels, you probably just go back through and delete what you don't want on those labels and then place them down next to it. Correct?
Yeah, so there's a couple. Yeah, great point. So there's a couple of ways we can handle that. You can just do a large data dump and be done with it, because the surveyor has the control on his equipment that says, okay, I just want to look at everything below the slab. So from 0 to -2 feet, I just want those points, and it will filter out a lot like the way Excel does that, right? So if I kind of show you here what he would run into.
Well, another thing too is that if there's a stud plate in the way or a stud in the way, his points are going to vary from those numbers anyways. And so having that exact coordinate location on that label doesn't really matter. All he'll need is, you know, a crosshair on there potentially of wherever that dot's going to be set up from the point layout.
Sure.
He could pull that point, and then we would import those new points in, and then it would match up, and then you could print a list of the actual coordinates that are field aligned, is I guess what I'm saying, right?
Right.
Okay.
Yeah, so that's how, I mean, you could do it in multiple ways.
Nice.
If you want to, I mean, you could go, it's so simple. I mean, you could just literally go to a 3D view. I'll go to my MEP view, and I'll go to a front view. And if I wanted to just export everything that was below the floor, so I would literally just make a window on everything that's above the flooring area here, and I'll filter those things out. So I'll just go grab my generic model. I can see I've got 100 points there, and I'll delete those. So now that they're deleted, my list has just gotten smaller, right? So I don't have any points above that area. And if I zoom in, you'll see that the only points I have are actually on that below that ceiling that I selected. So let's center in on, I don't know, one of these points, and then I'll orbit. Right. So
another question for you. Let's say way to choose the plane that those points get placed on? So obviously those points are being placed on one end or one end of the pipe, so the bottom end of the pipe, top end of the pipe. Can they be placed, like, for example, if we wanted to have all our marks where we're drilling through at 1.5 inches, because that's the usual height of your stud. If we wanted to have all those points on that that plane, could you like set up the automated point system to do that for you, where it sticks to one plane?
Oh, I see what you're saying. So I don't know of a way to do that. I think that the best way to do that would probably be after the fact. So I would select all of the instances that it already has placed, and then I would change the elevation. So the offset, you want it an 1.5 inches, right?
Yeah. Now my question is, when it places those, it's not just placing it where the pipe connects, it's placing it on the floor, top of subfloor, or wherever that level is, right? Is that how it's pulling those points? It's pulling it through floor penetration? Is that what it's doing?
It's placing it at an endpoint of the pipe. That's where it's placing it.
Oh, wherever they're plugging it.
Okay. Well, we would need that to pull from wherever it penetrates on the floor.
Now here's the thing. If you're trying to figure out where the floor penetration is, you can tell the robotic total station to ignore the Z value, the elevation. So
okay.
so what that does is it eliminates having to do anything with the points themselves.
Oh,
Right? So the solution here is kind of tricky because there's some things that you do to get the points, but then there's some things that you execute with the robotic total station. So in this list, this Z elevation would be totally ignored. And the cool thing about the robotic total station, when you're using your prism on the pole, for instance, the APL solution with the with BIM layout, your iPad will literally beep. It'll beep as you're getting closer, and then you'll hear a solid tone when you're right on the point.
Okay. All right, I get it. So basically, where that point exists on that pipe, it's basically when you're up on the top of subfloor and you're ignoring that Z elevation, when you go over that point of where that laser's hitting, it's just going to know that you're over that exact top point of that elevation of that layout point, correct?
Yes. I'm sorry, Brian. It's kind of hard to hear what you're saying. It sounds like there's some paper shuffling.
Oh, yeah, no, I'm not shuffling anything over here. That might be on Justin's end, possibly.
Okay.
Okay, yeah, no, what I'm saying is basically, so where that point exists for that connector, if you're setting your tripod up and you're on, say, level 1, right?
Sure.
And those points exist 6 inches below level 1. But if I go and I take my prism and I go over that point on the top of subfloor and I'm ignoring the Z value, it's going to know exactly where that point is and lines up with that 2 foot or with that 1 foot difference. It'll just know because it's pulling it off that vertical pipe, correct?
That's right. If you're ignoring the Z value, you can absolutely hover right over that XY location.
Nice. Cool.
Yep. Now, I think there's a way, when we export the points, I think there's a way that we can ignore the Z value here as well. Let me. Where did I find that the other day? I think set to elevate. I think maybe I'm confusing it with this. Set to elevation 100 feet. Regardless of what it's at, it's always going to be at the floor level.
Okay.
Yeah, I think what I'm talking about specifically is a robotic total station feature.
Okay.
And then one more question with that. Obviously, we're going to see it when you come out here. But just to wrap, we were discussing how you might mark the point with the total station. So what that is essentially just a vertical pole with the iPad attached to it that has obviously your leveling components to it. At the base, is it just a point, or?
Yeah, it's a very sharp. It comes down to a very sharp point, right? And you can do several things. A lot of guys will literally bend over and just use a Sharpie right where that point is.
Got it. Okay.
Now,
Yeah, so
can you do vertical studs with that as well? So like if you were trying to get hole marks for your 1/4 inch slope where they're going to drill, in the stud, could you create a point from the total station, not necessarily on just an XY plane, but on a Z plane?
yeah, I've done that on quite a few demonstrations. So the way that would work is you would find the location where the pipe is, right? So let me kind of walk you through that. Let's say we had this particular pipe that I've just selected, and that was penetrating through a wall. Okay, so we would place the point. Let me go to pipe points. I'll do a fence. I'll do a horizontal point on this guy, and I'll finish it. And then I'll do both. And I'll just use the standard, append the diameter. Yep. So now I've got my points there. Now let's say that there's a wall that cuts through it. What I'll do is I will use my alignment tool. Maybe I can do it here in this 3D view. Where is that? Oh, great. Now I lost the point. So what I would do is I would use the alignment tool and bring that into alignment with the wall, right?
Yeah.
And what that will do now is that has a point along the pipe and a point that's flush up against the wall. So I could literally rename this point or whatever I need to do. Now with my robotic total station, once I set it up and it's in that room on the inside where the wall is, I would literally use the laser point feature. It'll put a little red dot on the wall at the exact height that it's supposed to be.
Okay, next question is, will that work with sloped pipe and not just zero slope pipe?
So as long as you align everything, the point along the run, as long as you align that point and follow the slope, then yeah, it'll follow that.
Awesome.
And so that point will be locked to that pipe, though, correct? Since you placed it as a 0.4 pipe, it should slide along the run of the pipe, correct?
So once you place the point is free to roam around, and that's a good thing because we can follow the slope exactly where it needs to be. It won't slide along the pipe. I kind of get the question there. It's not going to slide along the pipe, but we can still leverage it without that feature.
Right. Gotcha. Okay. Cool.
Yeah.
So that wouldn't even be a problem at all.
Now, of course, there are a lot of different pieces of hardware that this works with. Any kind of robotic total station that's out there, you guys can use it. There is a revolution happening inside of the robotic total station industry right now. It used to be, and it still is, you can get robotic total stations, and they're awesome, but they cost a lot of money. I don't know if you guys have taken a look at that market yet or not, but some of them are in the range of $40,000 to $50,000, and that's without a controller. The controller is an additional $10K.
Yeah.
Right? So they're expensive is what I'm getting at. Then you have to have all the support equipment like the tripods, and so you're talking a big investment. So the revolution that's happening right now is kind of like, do you guys remember those big over-the-shoulder camcorders? You guys remember those?
Yeah.
Okay, GoPro. GoPro's kind of revolutionized the camera, the video camera industry. Super small, super cheap. There's like one button on it, and it does just as good of a job of recording high-definition video, right? There's all kinds of different small options that do high-definition recordings, including camera phones, right? So the robotic total station is going through that right now. Topcon, which is a manufacturer of robotic total stations, among a lot of other things, they introduced about a year and a half ago now, what's referred to as the Topcon LN, Larry Nancy, LN100. And it's a GoPro of total stations. It's a fraction of the cost, but it does just as good of a job. And if you guys are doing residential, this is a really good fit for you guys. And on top of that, our BIM layout solution, the iPad app, drives the TopCon LN100. It makes this very, very simple. And that's what I plan on bringing with me when I come to visit you guys in a couple of weeks.
Awesome. Awesome. Perfect. That's perfect.
So Jay, tell me this: what is you know, an article out? Leica, Autodesk, they're partnering. Is there going to be, you know what I mean? We're like a dealer here at Selby's. You know, not saying anything bad about TopCon, but you know, we're so.
Sure, Justin. Thank you so much for bringing that up.
By all means, I think you should definitely bring your TopCon LN100. I would love to see it as well. But,
okay.
you know.
Yeah, so Leica has one that's coming up pretty soon. It's just TopCon beat them to the market with their budget-style robotic total station. Trimble was the next one on board, and Leica's following up. They're going to release something. I just don't know when. But here's the thing. Autodesk is a leading provider of building construction technology software. And every manufacturer of hardware, including one of our biggest competitors, which is Trimble, every one of them wants to use the iPad, and we've nailed it, guys. You guys have to see this. We've nailed it. And it shows a little bit of a 3D view of your building model, and people understand that very easily. And if you're in the construction business, of course you understand floor plans. But if you were to give the same floor plan that a construction guy uses, if you were to give that floor plan to the owner, he's going to look at it and say, right? He doesn't get it, right? So it's kind of hard for me to imagine because I've been around them my whole life, my whole professional life, but some people just, they don't get floor plans, and it's hard for them to make sense of it. But when you show them an immersive environment like a 3D model and where the point is and how your tripod is tracking, your robotic total station is tracking your prism pole, that's some pretty intuitive thinking. And the way that they did it, they just nailed it. And Leica, as well as all of our competitors like Trimble and partners like TopCon, right, they're all wanting to be on that platform. So we're seeing more and more development on the iPad app within Autodesk and more adoption from Leica and other partners like TopCon as well as competitors like Trimble. So guys, that's kind of what I wanted to demonstrate for you. You saw what I did with manual points, automated points, how we leverage this in Excel and get this out. It's a pretty simple process. It's not very complicated. I think that if you guys sat down for like a couple of hours with this technology, you would nail it without the need for a lot of, 8-hour, 10-hour training courses or anything like that. I think that a few hours with the technology would get you well under your way with this technology.
And what we're kind of hoping when you come out here is we have, we have a house that we're working on. If we could, use that as an example, so like basically go into Revit, set our points, and do the whole in-house, point layout to the field and communication thing, like kind of just demoing that sort of relationship. I think that'll really put a good image in my boss's mind in terms of what we're trying to achieve, just so he can kind of see it tangibly. So,
okay.
Does that make sense?
I'm on board 100%. So here's what I'm going to need, Brian.
Yep.
I'm going to need the model or a sample of the model. Of course, all of this, anything that I share with you guys is completely confidential. I don't share it with anybody. And I'll do a little bit of prep just so I'm familiar with what you guys need, and I'll need a little bit of guidance. What do you guys want me to demonstrate how to find points on the field? So throw me a few scenarios, and we'll make it work with the model.
Awesome. Cool. Yeah. Well, I'll sit down with him after this call, and we'll get that prepared and sent your way.
Okay, that sounds good. And then also I'll be in touch, Brian, with the dates that we can make work to come out.
Awesome. Yeah, no, that'll be great. That's perfect. And
Okay.
then we'll get some of our contractors to go to the demonstration as well. So I mean, it won't just be us. We'll have other people in our area that
Yeah, that'd be great.
we'll have come. So architecture firms, stuff like that. So cool. This is great, Jay. Thanks. I appreciate it. I think that's about the best we can do over the phone for now. And then when you come here in person, you know, we can really iron it out.
One more question.
Tyler's got another question for you.
Sure, Tyler, go ahead.
So, again, the idea about a lot of the BIM ideas and the goal is to automate a lot of things, such as what you guys have done, obviously, with automating these point placements. I'm wondering, since one of our big workflows, or a big part of our workflow is using groups and then creating assemblies out of them, is there a way to place these points inside of a group or assembly and then have it work when you import it in the same way it does as if you were just placing it in that project?
Yeah, absolutely. Absolutely. So the beauty about how this works is there's a lot of repetitive things. Like you think about it, for instance, fire sprinklers in a commercial building. If you walk in any kind of office building and you look up, you'll see the fire sprinklers popped up everywhere. So we can embed not just in a family, but also groups or assemblies. We can embed these points.
That's perfect. That's what we're looking to do. So I don't know if you can switch to our screen or not. I can give you an example. I don't know if you have time right now.
Let me make you a presenter. Give me 1 second. Is it estimator?
Yes.
Okay,
Yep.
That's you. Let me make you a presenter. You'll see a prompt on your screen.
Awesome. Okay, cool. So I'll get this opened up real quick here. I guess I could do that. Sure, why not?
Yeah, the challenge has typically been in the
now,
past. I'm so sorry. Go ahead.
No, go ahead, Jay. I didn't mean to cut you off. Sorry.
Sure. I was just going to say that in the past, the technology challenge has always been if you embed a point, there's no way to renumber subsequent points because they're all the same, whether it's an attribute from AutoCAD perspective or the same parameter in Revit. So Autodesk point layout takes a different look at that, and it actually numbers the repetitive, right, whether it's a family or whatever, it numbers them sequentially. It's pretty clever the way it does that.
Wow. Yeah, that's a huge problem when making families and having something that's going to be, you know,
a numbering process. It doesn't like to change when you have two of the same thing. It gets confused.
Give me 2 seconds here. It's loading. Sorry.
Sure.
Shouldn't take this long. I'm surprised it's taking this long.
You know, I always have a performance hit when I'm broadcasting over the internet.
Right? Yeah, that's what's happening.
It's probably the graphics driver, the graphics card, because it has to share more than it's expecting to normally.
That's probably exactly what it is.
you're sharing with 3 computers.
Yeah. There we go. It's moving. Maybe. I can show you on our, while that's loading, basically under our Revit library here, we've got our assemblies, and we're starting to save all of our groups of those assemblies. And so you can kind of see it in the bottom left here, not very well. I mean, it's just a line diagram, but taking those points and embedding them into these groups, and then when we place these groups in the family, or I mean in the file, the project, those points would exist within these, so our points would be laid out for us. Yeah, it's going to be a pain in the butt. See if I can, this is going to bog it down even more, but just bear with me, please.
Sure.
There it goes.
Okay. So I'm gonna challenge you with this, Brian. download the trial and make the points that you think you're going to want to find out in the field, because you're going to know this better than I do.
Sure. Yeah, no, I can do that. That's totally fine. That one got a little bit funky, but basically these are all groups that are loaded in. So if you go down to our groups down here, we've got a series of the ones that we've loaded.
Yes.
So if you go over here and I'll place one, boom, hopefully that goes where I put it. Maybe not. Where is it? Let's just go to the plan view real quick here. Gotta move my go-to meeting thing was in the way. Plumbing first floor, not on the sheet. Grab our group. So there, just placing it right there, yeah. So then if I go into this, and we just go to view it in 3D now. So this little guy right here, we would embed those points. So we'd have one at that coupling, because that coupling's right where that 1.5 inches is. And then at the top, we'd have another point up here. And then those points would coordinate out in the field. And then basically when they go out there and they draw their points and we re-import that information to have this group move wherever those points move, would be pretty awesome.
Oh, I see what you're doing. Okay. So, okay, when we execute it out in the field, the guy's going to go with his prism pole, and he's going to be a couple of inches off, right? Maybe 1.5 inches or something.
Yep.
And so what he has to do, he has to take an action. When he's on the point that he says, this is where I'm going to put that stub up, he's going to press the button on the controller, whether it's the iPad or whether it's a full-blown robotic total station controller. He'll press the button. Now, that does two things. It registered that he staked out the point that you said, point number 2002, and it acquires the new geographical location, the updated one. So the thing about what we can do next is we can bring those points, not the staked out, but the verified ones, the ones that he pressed the button on, we can bring those points back in, okay? And we have an opportunity now. We have an opportunity to do a few things. We can move the points to the updated location. We can compare them, or we can import those points as new points. So we can, and I would suggest bringing them in as new points. So that way you can manually
making the adjustments yourself.
Yeah.
Yep. That makes complete sense. Because then you're not relying on the computer to determine those slopes, because something could get funky if it's embedded like that. So that makes complete sense.
Yeah.
Cool. Yeah, no, I think this will be great. I think, being able to see it in action, and, I think this is going to be great. So, awesome.
Good. I'm excited for you guys. I will see, Brian, if I can find, I just found the Revit the APL 2016 trial. I will see if I can find the 2015 trial.
Awesome. Awesome. Cool.
And if I find it, I'll send you a link, but, okay.
No, that's perfect. Thanks, Jay. We appreciate it, and we look forward to meeting you, and I think this is going to be a good learning experience for both of us, really.
Yeah, I think you're right about that.
Cool.
Great. So, okay, what I'm going to do next is I'm going to stop the recording, and we'll just chat for a couple minutes and then jump off the phone.
Sure. No, that sounds great.